You've been there, right? You're talking to an AI assistant or maybe using a smart app, and you get that sinking feeling that you're starting over again. You just gave it all the info it needed, but poof, it's gone. Well, it turns out that's not just some small bug. It's a massive technical problem. Today, we're going to dive into a really cool new design pattern that promises to fix it, to give our AI systems a perfect, persistent memory.
So yeah, let's start with that big question. Why does it feel like we're dealing with a system that has total short-term memory loss? You're planning a trip, you ask about flights, then hotels, and suddenly the app has absolutely no clue what city you're even talking about. This isn't just a glitch, it's a symptom of a much, much deeper issue in how these systems handle information.
And that problem? It actually has a name: the context crisis. This is the challenge that pretty much all intelligent systems are facing right now when they try to make smart decisions. See, they have to pull together bits of information from all over the place, and that info is changing constantly. That forgetfulness we feel, that's just the system failing to handle this crisis.
Okay, so let's break this down a bit. For an AI to be genuinely helpful, it needs to grab your profile, your latest activity, maybe some outside data like stock prices or the weather. But here's the rub. How do you keep all that info fresh, like down to the millisecond? And how do you make it explainable, so when you ask, hey, why did you recommend that? You get a real answer, not just a digital shrug. And how do you do all of that without your costs just exploding? That is the heart of the context crisis.
So you might be thinking, why can't we just fix this with the tools we already have? Well, the thing is, the approaches that work for simpler apps, they're just falling apart at the scale and speed that modern AI demands. Let's look at a couple of common ways people try to solve this, and why they just don't cut it anymore.
First up, you've got what's sometimes called the LLM anti-pattern. This is where the context is built from scratch for every single request. Just imagine that. Every time you ask a question, the system has to scramble to fetch your profile, your messages, your documents all over again. It's incredibly slow and super expensive, kind of like rebuilding your car from parts every single time you want to go for a drive. The real problem is the cost scales with traffic, not with whether the info has actually changed. The goal, what we're aiming for, is to completely flip that model on its head.
The other big anti-pattern is the good old static cache. And look, we all get how caches work. You store a copy of data so you can get to it faster. This is awesome for speed, but it creates two massive problems. First, the data is almost always stale. It's a snapshot from 5 minutes ago or an hour ago. Second, it creates what's called a provenance void. Basically, you have no idea where that cache data originally came from, which makes it impossible to explain anything. What we really want is a memory that keeps itself fresh automatically, and where every single piece of knowledge knows exactly where it came from.
So, if the old ways are broken, we need a new way forward. And this brings us to the solution: a new architectural pattern that totally rethinks what system memory can even be. It's called Reactive Composite Memory, or RCM for short. Now, what I find really fascinating here is the wording. RCM treats context as a living, versioned, governed artifact. It's not just some temporary file or forgotten cache entry. No, it's a formal piece of knowledge that has a version number, it knows its own history, and, this is the key, it updates itself reactively. The second one of its sources changes, it updates. It's really the difference between a system with amnesia and one with a living, working memory. Okay, before we go any deeper, let's get a few things straight about what RCM is and what it isn't. It is a platform-agnostic design pattern. Think of it like a blueprint you can build with tools you might already use, like Kafka or Flink. It is not a specific product you can just go buy off a shelf. And this is super important. It's not a replacement for your databases or streaming engines. It's a pattern that works with them, organizing how they all play together to create that intelligent context.
All right, so how does this whole thing actually work? Let's walk through the data flow. The big idea here is a clean, one-way street for information that takes all these raw changes and turns them into structured, reliable knowledge.
So it all kicks off on the left with source signals. These are basically just raw change feeds from your databases or event streams or whatever APIs you have. These changes flow into what are called context views, which are like declarative recipes for how to combine all those different sources. Then the materializer, that's the engine, it executes these recipes, but only when a source actually changes. The output? Well, that's the star of the show, a frame, which is a versioned, unchangeable snapshot of knowledge. And finally, subscriptions deliver these frames to anything that needs them, like an AI agent or user dashboard.
Let's just hang on this idea of the frame for a second, because it is the absolute core of RCM.
Think of it like a perfect, tamper-proof package of knowledge. It's immutable, which means once it's created, it can't be changed. It can only be replaced by a newer version. And every single frame comes with its own receipt, a super detailed record of exactly which data sources and what logic were used to build it.
And this receipt is what makes it so powerful. Every frame's header has its own identity and version number, the exact time window it represents, and its provenance. Now this provenance part, that's the secret sauce. It lists the exact input data it used and even includes a cryptographic hash, like a fingerprint, of the logic plan. This means every piece of knowledge is totally self-describing and auditable. You can always trace it back to where it came from. No more black boxes.
So, okay, we've got this really elegant system of reactive updates and these versioned, auditable frames. So what? What's the payoff? Why does any of this matter in the real world? Well, this is where we tie everything back to that context crisis we started with.
This table just brings it all home. I mean, look at this transformation. Before RCM, freshness is basically a mystery. You're just crossing your fingers and hoping your data isn't too old. Afterwards, it's something you can actually measure. Explainability goes from being painful detective work to being auditable right from the start. And here's the kicker on cost. It stops scaling with how many people are using your app and starts scaling with how much your data is actually changing. That is a massive efficiency win. It's a total shift from chaos to control.
I absolutely love this quote from the source material because it puts the whole thing in perspective. Think about it. Before REST, everyone built web APIs in their own custom, chaotic way. REST came along and created a standard that unlocked the modern web as we know it. The argument here is that RCM does the exact same thing for context. It standardizes how intelligent systems build, version, and share knowledge. It's a foundational building block for the next generation of AI.
And that just leaves us with one last big question to think about. We're building AI into everything now. Our cars, our customer service, you name it. What new possibilities open up when these systems don't have amnesia anymore? What happens when they have a perfect, auditable, and explainable memory of every single thing that's happened? That's the future that a pattern like reactive composite memory starts to make possible.